We are given this function a of t equals 125 times of 3.2 raised to the power of negative 0.5 t, where a of t represents the amount of the radioactive material in grams and t represents the number of months after initial measurement. So let's start to answer these questions. Now let's do the part A. In part A, we have to find the initial measurement, that is at t equal to 0, we have to find the amount of the radioactive material. So let's answer this. I'm going to plug in t equals 0 into this equation. So therefore this becomes a of 0 equals 125 times 3.2 raised to the power of negative zero point 0.5 times of t equal to 0. So this becomes negative 5 times 0. And we can simplify this. This equals 125 times of 3.2 raised to the power of negative 0 is, we can consider this as 0, and a number raised to the power of 0 equals 1. So therefore this becomes 125 times 1, which is 125, and should be in grams. So at initial measurement, uh, there is about 125 grams of radioactive material. We now answer part B, that is, we have to find the amount of radioactive material after 2 months. So for that, we have to plug in t equal to 2 into the function. So we say t equal to 0, a of 2 equals how much? So let's find a of 2 by plugging in t equal to 0 into the function. So therefore this becomes 125, 3.2 raised to the power of negative zero point 0.5 times of 2, and this equals 125 times of 3.2 raised to negative zero point 0.5 times 2 is 1, so it becomes negative 1. We can plug this into the calculator, and when we do that, we get the value as 39.0625 grams. So this is the amount present after 2 months. In part C, we have to find the amount after 10 months. So we can plug in t equal to 10 into the function. So if t equals 10, we should find the a of 10. Let's do that. A of 10, this equals 125 times 3.2 raised to the power of negative zero point 0.5 times 10. Negative zero point 0.5 times 10 is negative 5. So this simplifies to 125 times of 3.2 raised to the power of negative 5. We plug this into the calculator, and when we do that, we get 0.3725 grams. So this is the amount present after 10 months. And in part D, we have to determine how long it takes to decay to 25 grams. So let's do that. So here we have to find the time it takes to decay to 25 grams, which means A of t equals 25, and then we have to find the time. So we are going to plug in A of t equals 25 into the function. So therefore this becomes 25 equals, the function is 125 times of 3.2 raised to the power of negative zero point 0.5 t. So we will determine t from this equation. First, I divide both sides by 125. So therefore, it becomes 25 over 125 equals 3.2 raised to the power of negative zero point 0.5 t. Now 25, we divide 125. This goes 5 times. This goes 1 times. So this is basically 1/5 equals 3.2 raised to the power of negative zero point 0.5 t. We then apply natural logarithm to both sides so that we can solve for t. So when we do that, we get natural logarithm of 1/5. This equals natural logarithm of 3.2 raised to the power of negative zero point 0.5 t. And when we apply the properties, the power rule of natural logarithm, This power comes in front and gets multiplied with natural logarithm of 3.2. So this is equivalent to writing of negative zero point 0.5 t times of natural logarithm of 3.2. This side we have a natural logarithm of 1/5. We now solve for t from this equation, which means we just have to keep the t on this side and divide by this quantity, that is negative zero point 0.5 times of natural logarithm of 3.2. And when we do that, we get the expression for t. This equals natural logarithm of 1/5 divided by negative zero point 0.5 times of natural logarithm of 3.2. We can plug this into this calculator, and when we do that, we get approximately the time as 2.77 months. So you can see that this, when approximated to close a whole month, it takes about 3 months. This can be approximated to 3 months. And so we have answered all parts of this question.